It's a question almost everyone has asked at some point in their lives. If the universe had a beginning, then shouldn't it have an end? If you could travel through space forever, would you eventually reach a giant wall? Would you find another universe, or is there simply nothing? The truth is, the answers are far more stranger than most people realize. In this video, we're going to explore what the universe actually is, why scientists don't believe the Big Bang was an explosion in space, why the observable universe isn't the entire universe, whether the universe could be infinite, what some physicists think might have existed beyond it, and why one simple question, why is there something instead of nothing, remains one of the greatest mysteries in all of science. Have you ever wondered what would happen if you could travel forever? Not for 1,000 years, not for 1,000,000 years, I mean forever. If you kept flying through space in one direction without stopping, would you eventually reach the edge of the universe? Would there be a giant wall where everything suddenly ends? Would you enter another universe, or would you simply continue traveling forever? At first, the answer seems obvious. Everything around us has boundaries. Your house has walls. A country has borders. Even Earth has an atmosphere that eventually gives away to outer space. So naturally, we assume the universe must have an edge too. But what if I told you that one of the biggest discoveries in modern physics is that the universe doesn't have to follow the same rules as the objects we experience every day? To understand why, we first need to understand what the universe actually is. Most people think of the universe as a giant empty container filled with stars, planets, galaxies, and black holes. It's easy to imagine space as a massive room that everything exists inside of it. But according to Einstein's general theory of relativity, that's not really what space is. Space isn't just an empty stage where everything happens. Space is something physical. It can stretch, it can bend, it can ripple like a pond when massive objects move through it. Gravity itself isn't a mysterious force pulling objects together. Instead, massive objects like stars and planets bend the fabric of spacetime, and everything else follows those curves. The idea alone completely changes how we should think about the universe. Around 13.8 billion years ago, our universe was unimaginably hot and dense. This event is known as the Big Bang. But despite what movies often show, the Big Bang was not a giant explosion that happened somewhere in space. There wasn't an empty room waiting for the universe to explode into. Instead, the Big Bang marks the beginning of the expansion of space itself. Imagine drawing hundreds of tiny dots on the surface of a balloon. Now, begin inflating the balloon. Every dot moves farther away from every other dot. If you were one of those dots, it would look like every other dot was moving away from you. More importantly, none of those dots would be the center of the expansion. Every dot would think it was surrounded by everything else expanding away. Our universe behaves in a surprisingly similar way. Galaxies are not racing through empty space like cars on a highway. Instead, the space between galaxies is stretching. This is exactly why nearly every distant galaxy appears to be moving away from us. It's not because Earth occupies some special location in the cosmos. In fact, if intelligent life exists somewhere billions of light years away, they would observe the exact same thing. they would also conclude that galaxies are moving away from them in every direction. That leads to one of the strangest facts in cosmology. Every observer in the universe sees themselves at the center of their observable universe, not because they actually occupy the center of all existence, but because the observable universe is simply the portion of space whose light has had enough time to reach the observer. This is where many people become confused. You've probably heard that the universe is about 13.8 billion years old. So, shouldn't the farthest thing we can possibly see be 13.8 billion light years away? Surprisingly, the answer is no. The observable universe actually has a radius of roughly 46.5 billion light years, making it about 93 billion light years across. That number seems impossible at first. How can we see something that's farther away than the edge of the universe would seem to allow? The answer is that while light was traveling towards us for billions of years, the universe itself continued expanding. Imagine standing on one end of an airport moving walkway while your friend stands on the other. As they begin walking toward you, the walkway itself starts carrying both of you farther apart. They can still eventually reach you, but the time they do, the distance between where they started and where they ended is much greater than the distance they originally had to travel. The expanding universe works in a somewhat similar way. Everything we can currently observe, the hundreds of billions of galaxies, each containing hundreds of billions of stars, is the only observable universe. It is not necessarily the entire universe. Beyond what we can see could be trillions more galaxies, infinitely many galaxies, or something even stranger. The truth is, we simply don't know because light from those regions hasn't had enough time to reach us. This raises another fascinating question. If the observable universe has a limit, does that mean the entire universe also has a limit? Our intuition says yes, but mathematics and physics suggest something stranger. To understand why, imagine an ant walking across the surface of Earth. The ant has no idea it's living on a sphere. From its perspective, the ground appears flat. It can only see a tiny portion of the world around it. But if that ant could somehow walk forever in one direction, it would eventually return to the exact same place it started without encountering the edge. Earth is finite, yet it has no border on its surface. Now imagine scaling that idea up, not into 3 dimensions, but into something our brains aren't built to visualize, a 4-dimensional shape called a hypersphere. Physicists don't literally claim the universe is a hypersphere, but mathematically it's one of the models that could describe a finite universe without an edge. In this picture, if you somehow traveled in one direction for an unimaginable amount of time, you wouldn't smash into a wall. You might eventually return to where you started, just as the ant does on Earth. The strange part is, this doesn't require the universe to exist inside some larger empty space. That's one of the hardest ideas to accept, because every experience we've ever had tells us that everything exists inside something else. Your bedroom is inside your house. Your house is inside your neighborhood. Earth is inside the solar system. The solar system is inside the Milky Way. Our brains naturally keep asking, okay, so what is all of that inside of? Physics may be telling us that this question doesn't necessarily make sense. Imagine someone asked you, what's north of the North Pole? At first, it sounds like a perfectly reasonable question, but the moment you reach the North Pole, every direction you can walk is south. There simply isn't a place that's farther than north. The question itself breaks down. Many cosmologists think asking what's outside of the universe may be similar. It isn't that we don't know what's outside. It's possible that Outside simply isn't a meaningful concept if space itself is all that exists. The idea feels deeply unsatisfying because our minds crave containers. We instinctively believe that if something exists, it must exist inside something larger. But that's an assumption shaped by living on Earth, not necessarily a rule of reality itself. This is one of the reasons Einstein completely transformed physics. Before general relativity, people imagined space as an empty stage where matter and energy acted out their roles. Einstein showed that space-time is part of the play itself. It bends, stretches, ripples, and evolves. In 2015, scientists directly detected gravitational waves for the first time, tiny ripples traveling through space-time itself after two black holes collided over a billion light years away. We didn't detect matter moving through space, we detected space itself vibrating. If space can bend, stretch, and ripple, perhaps asking what's inside of is like asking what's a thought inside of. Maybe the question assumes something that doesn't have to be true. Another misconception people often have is that the universe is expanding into something it isn't. Imagine baking raisin bread. Before placing the dough in the oven, the raisins are close together. As the dough rises, every raisin moves farther away from every other raisin. From the perspective of one raisin, every other raisin appears to be moving away. But the raisins aren't moving through the dough. The dough itself is expanding. Our universe behaves similarly. Galaxies are mostly being carried apart because space itself is stretching. That's why astronomers believe distant galaxies moving away from us. The farther away they are, the faster they appear to recede. This observation made by Edwin Hubble nearly a century ago became one of the strongest pieces of evidence that the universe is expanding. Then, another discovery changed everything again. In 1998, astronomers expected the expansion to be slowing down because gravity should gradually pull everything back together. Instead, they discovered the exact opposite. The expansion of the universe is accelerating. Something is causing space to stretch faster and faster. We don't know what it is. Scientists call it dark energy, but despite the name, this isn't an explanation. It's a label for something we observe but don't yet understand. Current measurements suggest that roughly 68% of the total energy content of the universe is dark energy. About 27% is dark matter, another mysterious substance that doesn't emit light, but whose gravity helps hold galaxies together. Everything you've ever seen, every star, every planet, every black hole, every tree, every person, makes up only about 5% of the universe. Think about that for a moment. Everything humanity has ever observed directly accounts for only a tiny fraction of reality. Sometimes people ask, have we almost figured out the universe? The honest answer is, not even close. We know enough to build spacecrafts, split atoms, and detect black holes billions of light years away. Yet, about 95% of the cosmos appears to consist of things we still don't fully understand. The deeper we look into reality, the stranger it becomes. And perhaps the strangest mystery of all isn't what the universe is expanding into. It's whether the universe has an edge at all, or whether the idea of an edge only exists because our human brains were never designed to imagine reality on this scale. At this point, you might be wondering something that's almost impossible not to ask. If the universe began 13.8 billion years ago, then what existed before it? It's one of the oldest questions humanity has ever asked, and surprisingly, modern physics doesn't have a definitive answer. The first thing we have to realize is that the question itself might be misleading. Think about this. If I asked you what happened before yesterday, you would naturally answer the day before yesterday. Every event in your life has always had another event before it. So your brain expects time to stretch endlessly into the past. But according to Einstein's general relativity, time and space are woven together into a single fabric called spacetime. If the Big Bang marked the beginning of space itself, it may also have marked the beginning of time itself. If that's true, asking what happened before the Big Bang could be asking, what's north of the North Pole? The question assumes that before exists when it may not. That's an incredibly difficult idea to accept because our entire lives are built around cause and effect. Every birthday comes after the one before. Every sunrise follows a previous night. Every choice comes after another moment in time. We have never experienced a reality where time itself has a beginning. Of course, not every scientist agrees that the Big Bang was truly the beginning. Some theories suggest that the Big Bang wasn't the start of everything, but rather the beginning of our observable universe. One idea is called the Big Bounce. Instead of the universe beginning from absolute nothingness, this theory suggests that a previous universe may have collapsed under its own gravity. Instead of ending in a final singularity, that collapse could have triggered another expansion, our Big Bang. In this picture, the universe goes through endless cycles of expansion and contraction, almost like a cosmic heartbeat. It's an intriguing possibility, but at the moment, there is no direct evidence that this is how our universe works. Another possibility comes from the idea of cosmic inflation. According to this theory, the universe experienced an unimaginably brief period of exponential expansion, just fractions of a second after the Big Bang. Inflation explains several puzzling features of the universe remarkably well, and many observations support the idea of inflation occurred. But some versions of inflation lead to an even more astonishing possibility. If inflation never completely stops everywhere, then our universe may be just one bubble in an enormous cosmic foam. While inflation ends in one region, creating a universe like ours, it could continue elsewhere, constantly producing new universes. The idea is known as an internal inflation, and it's one of the leading universe hypotheses. Imagine blowing bubbles into the air. Each bubble is separate, with its own interior. In some multiverse models, every universe is like one of those bubbles. They may have different physical laws, different numbers of dimensions, or even different values of the fundamental constant of nature. If that's true, there could be universes where stars never form, where chemistry doesn't work the way ours does, or where life as we know it could never exist. It's an incredible idea, but it's important to be clear. There is currently no direct observational evidence that other universes exist. The multiverse is a scientific hypothesis, not an established fact. Then, there are theories involving extra dimensions. Right now, we experience three dimensions of space, length, width, and height, along with one dimension of time. But some versions of string theory suggest that there could be additional spatial dimensions curled up so tightly that we can't detect them in everyday lives. These dimensions would be unimaginably small, everything at scales far beyond anything our current technology can directly observe. If that's true, reality could be far richer than anything we can perceive. Then there's perhaps the strangest idea of all, that nothing may not actually exist. When most people think of nothing, they imagine complete emptiness. No stars, no planets, no light, no atoms. But in quantum physics, empty space isn't truly empty. Even a perfect vacuum is filled with fluctuating quantum fields. Tiny particle-antiparticle pairs can briefly appear and disappear, borrowing energy from the vacuum in ways that are allowed by quantum mechanics. This doesn't mean that the entire universes simply pop into existence from absolutely nothing, but It does show that what physics call a vacuum is far more active than our everyday idea of emptiness. That's one reason the phrase the universe came from nothing can be misleading. In science, nothing often refers to a quantum vacuum, a state that still has physical properties and laws, not the philosophical idea of absolute non existence. And that leads us to what many philosophers and physicists consider the deepest question anyone can ask. Why is there something instead of nothing? Not just stars, not just galaxies, not just the universe. Why do the laws of physics exist at all? Why does mathematics describe reality so astonishingly well? Why is there a universe capable of producing hydrogen, stars, planets, life, consciousness, and minds that can ask these very questions? Despite of all humanity's discovery, no one knows the answer. We've mapped the human genome, we've landed robots on Mars, we've detected black holes colliding billions of light years away. We've measured the faint afterglow of the Big Bang itself. Yet, when it comes to explaining why reality exists in the first place, science reaches a boundary where evidence runs out and mystery begins. Some people look to philosophy, others look to religion, others believe future discoveries in physics will eventually reveal the answer. The honest truth is that we don't know, and that's okay. Science has never been about pretending to have all the answers. It's about asking better questions and following the evidence wherever it leads. Perhaps one day humanity will discover whether the universe is finite or infinite, whether time had a true beginning, whether other universes exist, or whether our entire understanding of reality is only a small piece of a much larger picture. Until then, every time you look up at the night sky, remember this. Everything you've ever seen, every star visible to your eyes, every galaxy captured by our most powerful telescopes exists within a tiny window of an unimaginably vast cosmos that we're only beginning to understand. Maybe there's no edge to the universe. Maybe there are countless other universes beyond our own. Or maybe reality itself is stranger than anything we've ever been able to imagine. The most incredible part isn't that we don't have all the answers. It's that on a small rocky planet orbiting an ordinary star, a species evolved that can look into the darkness, ask these questions, and spend generations searching the truth. And perhaps that endless search is one of the most remarkable things the universe has ever produced.